All right, here are the video solutions for lesson 9 in unit 5. So we've got 4 different graphs here, and we want to determine the value of k so that g of x is equal to f of k times x. So in the first one here, remember these are horizontal stretches and compressions, and so it looks like a horizontal stretch to me. Our y values, if we're comparing these 2 points, the y values stayed the same, but the g function is stretched out from 10 to 30. So we know that our scale factor is going to be between 0 and 1. Since it's a stretch, it's a fractional scale factor. Kind of counterintuitive, as we discussed. So what we want to do is realize that if g of x is going to equal f of x times some constant k, we want to use these 2 points, 10, 0 and 30, 0, and realize that if I put 30 in for x, in g of x I get 0. So g of 30 gives me 0, but f of 10 gives me 0. So how can I make these equal some scale factor there? So if that's telling me that k times 30 has to equal 10. In order for me to get 0 out of my function f, I need a 10 in there. So if I put 30 in for x in g, I need to use a scale factor then in my function f of x of 1/3, because then I will get 10, which is 0, the outcome is 0, or the output is 0 for my function f. So our scale factor here for this one is 1/3. Let's go to the next one. This one is f of x is the solid one, and g of x is the dashed one here. So it looks like another stretch. Our y coordinates stay, our output coordinates stay the same, but it's a stretch from f of x to g of x. So we want to write g of x in terms of f of x here. So I know that g of 5 gives me 0, and I know that f of 3.125 gives me 0. And so I want to figure out a scale factor. So I need to put if g of x is equal to some number, f of some number times x, I need to figure out what that k value is. So this k, when I put 5 in for x, I need to multiply that by some constant k so that I get 3.125, because then that will give me the 0 output for f. So my scale factor is 3.125 divided by 5. And if I take that over to decimals, calculator or someplace quick, 3.125 divided by 5 is 0.625. So k is equal to 0.625. And then I can write g of x is equal to f of 0.625 x. I forgot to write that over here. G of x would be equal to f of 1/3 x for this first one. Okay, from g of x to, or from f of x to g of x here, it looks like a compression. So because g of x is this one and f of x is the dashed one in this case, so we're compressing that function a bit. Our y output values are staying the same, so it's a horizontal compression. And so let's look at, let's see, we have g of 0.277 is equal to 1, and f of 0.693 is equal to 1. So in order to write g of x in terms of f of x, we need to use some multiplier there, k, and if we write these in terms of the output 1, so let's see, so I need to find a value k so that when I put 0.277 in for x, I'm going to get 0.693 because that's the value for the function f of x that gives you a 1. And so when I do my division now, I've got dividing by 0.277, and so I get something greater than 1 here. So I knew that in this case, k was going to be greater than 1 because it was a compression. And so I want to take 0.693 and divide by 0.277. And I get approximately 2.5 for a scale factor for that one. So I get 2.5 here. Let's see. So another way of looking at this, possibly, that might help explain. So if I have an x value here of 0.693, my g of x is going to be 1, because if I put 0.693 in for x, I get 1 out for y. Let's see. What I meant to say here is if I put 0.277 in for x, I get 1 for y, because that's the g of x function down here, the solid line here. So I'm talking about this point. But then if I put that in for x, the function f of x, I need to multiply that by 2.5. And then I'll get a 1 out in my function f. So the outputs stay the same and the inputs change for horizontal compressions and stretches. So on this last graph, it looks like our outputs are staying the same again. We have 4, 2 compared with -8, 2, and then 1, 1 and -2, 1. So there's a couple of things going on in this one. If this is our g of x here, this is our resulting function after a transformation of this one, it looks like a stretch because you're further away from the x-axis with g of x than you are with f of x. So I'm expecting this to be a scale factor that's between 0 and 1 again. So oh, that's not right. So I'm expecting our scale factor to be between 0 and 1. So let's take a look at it. Let's see. F of 4 is equal to 2, and g of -8 is equal to 2. So I'm going to take my result here. Let's see, if I put a -8 in for x, I'm going to want to multiply that by some number so that I will get 4, because that's what I need for my function f to be 2 as an output. So dividing by -8 on both sides, I get k is equal to negative 1/2, and that's your scale factor. And that makes sense because not only did it draw the function away from or stretch it away from the axis, the y-axis, it also flipped it. So that negative out there in front of the 1/2 flips it over the y-axis. So scale factor of negative 1/2 there. So we can write g of x is equal to f of negative 1/2 x. So if I put, again, if I put negative 8 in for x, if I show my tables here, then g of x is going to be 2, but f of negative 1/2 x, which would be f of 4, we know that's 2 then. So kind of a different way of looking at it too. Hopefully that helps. Number 2 says f of x is equal to x times the quantity x minus 5 times the quantity x plus 2 times the quantity x plus 5. So decide if the reasoning about each of the following functions is correct. So let's take a look. Andre says that g of x, 0.1 times x times the quantity 0.1 x minus 5 times 0.1 x plus 2 times 0.1 x plus 5 is obtained from f by scaling the inputs by a factor of 0.1. And it looks like that's true. This would be a horizontal scale factor because you're multiplying each one by 1, and in fact it would be a horizontal stretch. So this is true because each input value are scaled by a factor of 0.1. Claire says this graph is a vertical shift of the graph of f down 100 units. So we're looking at this original function again. So so we can look at, when we're talking up and down, let's look at our y-intercepts here. So h of x here intercepts at 0, 100. If we put 0 into the original function, that's going to go through at 0, 0. So it is not a shift down. It could possibly be a shift up, but this is false. And then Diego says that putting that negative out there is the reflection of the graph over the y-axis. And Diego is not correct on that. We would have to make a lot more changes here than that, but it looks like just this negative out in front of everything is going to reflect the y-coordinates, and when the y-coordinates are reflected, it's a reflection over the x-axis. So number 3, a bacteria population in thousands is modeled by this function, f of d is equal to 30 times 2 to the d. So where d is the number of days since it was first measured. The function g gives the bacteria population in thousands weeks after it was first measured. Express g in terms of f and explain your reasoning. So since we know that there are 7 days in a week, we would know that we would have to somehow make that d up there. So we have f of, let's just do x, is 30 times 2 to the x. So this has to become weeks instead of days. And so g of x then would just be simply 30 times 2 to the 7x. I think that's the easiest way to think about that. So g of x is equal to f of 7x. Then we would get a week. Number 4, the height of a hot air balloon in feet m minutes after takeoff is modeled by the function f of m is equal to 16m. How many minutes does it take for the balloon to reach 200 feet? So, let's see, we would have 200 then equal to 16m, and so m would be 200 divided by 16, which is 12.5, I think. Yeah, 12.5 there, so 12.5 seconds. The hot air balloon would be 200 feet high. Another balloon takes off 5 minutes later and rises at the same speed. Write an equation for the function g, where g of t is the height in feet of this balloon in terms of m, and explain your reasoning. So another balloon takes off 5 minutes later, so g of t, or m, is equal to 16 times m minus 5 then, since it's taking off 5 minutes later. So when m is equal to 5, the second balloon is just about to take over, or take off, and that would be 5 minutes later than the first one. So we want to sketch the two functions f and g. So at 0, the function f is 2, it starts out at 0, 0 here, 0 time, 0 height, and then at 12.5, it's up to 200 here. So we can draw that in like that. And then the next one, at 5 minutes later, it's still at 0, but the speed is the same. So we're just going to make that a parallel line to the first one. It's rising at the same rate. So number 5, here's the graph of a function reflecting f across the x-axis and then across the vertical line y is equal to 1. Takes this graph back to itself. Tyler says that this means it's an odd function. Do you agree? No, it has to be reflection over both axes. So reflections over the x and y axes denote, or let's see, how can we say that? Result, or let's see, let's just say odd functions are reflections over the x and y axes without change. So they don't change if you reflect them over the x and then the y axis. But this one you can't use the vertical line x is equal to 1. Number 6, the population of sloths in an area has been increasing by 5% each year since 2000. Let P model the population P of T in thousands of sloths T years after the year 2000. The graph of P of T is equal to 1.05 to the T, has a general shape that fits the data. Find a scale factor for K so that capital P of T is equal to K times P of T fits the data. So let's take a look at 5 maybe. So 5 years since 2000. So our P of T is equal to 1.05 to the 5 is, let's find out what that is. So 1.05 raised to the 5 power is 1.27 to 1.28. Okay, so here our P of T is equal to 15.7. So 15.7 is some scale factor of this function here. So let's take K times 1.28, and then we'll divide by 1.28 on both sides and figure out what our scale factor is. So this is definitely a vertical stretch. Let's see where, I forgot it already. 15.7 divided by 1.28. And we get 12.26, so 12.3 is our scale factor there. And that's it. So I hope this helped. Let me know if you have any questions. And that's your final assignment for this year.